So differential equations is something that I don't think I spent enough time on your review of application of integration, but I knew we were going to spend a lot of time on your FRQs. So what makes differential equations a BC problem is if it has Euler's method or logistic problems. This one does ask about Euler's method. Let's go ahead and read the problem. Consider the differential equation dy dx equals 1 minus y. Let y equals f of x be the particular solution to this differential equation with initial condition f of 1 equals 0. For this particular solution, f of x is less than 1 for all values of x. Use Euler's method starting at x equals 1 with 2 equal steps to approximate f of 0. Show the work that leads to your answer. Obviously a typo there. So the Euler's method that I taught you is to make a table. So I said always start out with your x. Your formula for Euler's method is change in x times your derivative. Now, a derivative could be written as dy dx. It could be written as f prime. It could be slope of a tangent line. But you're multiplying those two together. And then I said y. Now, our initial condition in our problem is 1, 0. And then our change in x. If we are starting at 1 and going to 0, that means we're going backwards. So we're not adding 1/2, we're subtracting 1/2. So our next x value will be negative 1/2. And our next x value will be 0. So that means that in this problem, our change in x is negative 1/2 every time. And then in this problem, our derivative is 1 minus y. So this has our initial condition, our particular change in x for this problem, and our particular derivative for this problem. So then when I fill out this piece, I use the previous x and y. So this is going to be negative 1/2 times 1 minus 0. So negative 1/2 times 1 is negative 1/2. And then we take our y value and add our new y value. So 0 plus negative 1/2 means that our new y value is negative 1/2. And then we start the process again. Our change in x is still negative 1/2, and it's 1 minus y. 1 minus our y value is negative 1/2. So this is negative 1/2 times 3/2, which is negative 3/4. Now what I'm going to do is take this negative 1/2 from the previous, always the previous. So I use the previous y value when I plugged in my y value, and I know now I use it again when I do negative 1/2, which is the same as negative 2/4. And I add my column, and I get negative 3/4. And when I add them, I get negative 5/4. So f of 0 is approximately negative 5/4. So this one was 1 point for using Euler's method, which means you had your change in x times your derivative, and you had 2 equal steps here. Now in part B, it says to find the limit. So when you find the limit, you're always supposed to try and plug in f of 1. So, or whatever it's approaching. So the limit as x approaches 1 of f of x is equal to f of 1, which is 0. The limit as x approaches 1 of x cubed minus 1 is equal to 1 minus 1 is 0. Now, how did I get f of 1 equals 0? Here, it was given to me. F of 1 is 0. And here I just plug the number in. Now, L'Hopital's rule, if you get an indeterminate form 0 over 0, L'Hopital says you can take a derivative of the top and a derivative of the bottom separately and try to substitute in again. So this is going to turn into the limit as x approaches 1 of f prime of x over 3x squared. Now, I took a derivative of the top, I took a derivative of the bottom, that's 0. And now I tried to rect sub again. Now, if I need to find, this is going to be f prime of 1 over 3 times 1 squared. So it's going to be something over 3, which would not be an indeterminate form. Now, how do I find f prime of 1? That's the same as saying, what is dy dx at x equals 1? Well, when x is 1, what is my y value? When x is 1, again, back to our initial condition, when x is 1, y is 0. So we need to find our derivative at 1, 0. So we have a formula for our derivative. dy dx is equal to 1 minus y. Our y value was 0, so 1 minus 0, so 1. So our limit is 1/3. So when I plugged 1 into the top, I got 0. When I plugged 1 into the bottom, I got 0. So L'Hopital said if you get 0 over 0, you can take a derivative of the top and bottom separately and retry direct sub. This one was tricky because you had to realize that when I'm finding a derivative at 1, that's the same as dy dx at 1 comma, and I knew that 1, 0 was my ordered pair, and I could plug it into the derivative they gave me. The nice thing about the AP exam is if you can't do B, it doesn't mean you can't do C. So let's move on to C. So when I look at C, dy dx equals 1 minus y. So when I multiply the dx over, that's going to give me dy equals 1 minus y dx. Now I've marked my left side, my y side, and my right side, my x side. So I have to multiply both sides by 1 over 1 minus y. So these cancel. So now I have 1 over 1 minus y dy equals dx. I now have 1 point out of 5. I've separated my variables. Here's the bad news, guys. AP says if you separate your variables incorrectly, note 0 out of 5 on this problem, you're done. Next thing I'm going to do is integrate both sides. So this is 1 over u basically, but this is a linear. So the antiderivative of 1 over u is ln of 1 minus y divided by the derivative of the inside, which is divided by -1. I could do u sub if I wanted to, I'd get the same answer. But remember, if it's a linear, it's 1 over a linear, which is ln of the linear, divided by the derivative of the linear. So this is going to equal the derivative of 1 is just x. And here's the important part, constant of integration plus c. Here's the thing, AP says, so now I have 1 point for the integration and 1 point for the plus c. AP says no plus c, 2 points max. Now I have to solve for c by plugging in my initial condition, which back to that 1, 0 they gave me. So I like to write over it. This is my x value and this is my y value. So this becomes ln of 1 minus 0 over negative 1 equals 1 plus c. I like to plug it in before I do any math so that I get my point for use as my initial condition without making some silly mistake. So ln of 1 is 0, 0 divided by anything is 0, so this whole thing goes away, so c is equal to 1, or negative 1. So here I go. So I'm going to go back, ln of absolute value 1 minus y over negative 1 equals x minus 1. So we have 4 out of our 5 points. The last point is always the hardest point to get because you have to solve for y equals correctly. So the first thing I'm going to do is multiply both sides of this by negative 1. I hope y'all like my new pencil. I love my new pencils. So this is going to be ln of 1 minus y equals negative x plus 1. Now, how do I get rid of ln? I exponentiate both sides base e. So e is my base, and all of this is the power. Oop. Except for I write so hard that this 0.7 lead is hard for me. So these are going to cancel, and I have the absolute value of 1 minus y equals e to the negative x plus 1. Remember, how do you get rid of the absolute value? You plus or minus both sides. So 1 minus y equals plus or minus e to the negative x plus 1. Then move the 1 over and divide both sides by negative. So negative equals plus or minus e to the negative x plus 1 minus 1. When I divide both sides by a negative, I get y equals 1 plus or minus e to the negative x plus 1. Now, AP says you can't give me 2 equations. You have to pick which equation is correct. So what you have to do is you have to go back to your original problem, or your initial condition, I'm sorry. This is x, this is y. So to get 0 is equal to 1 plus or minus e to the, so negative 1 plus 1. So for this to be true, it has to be the negative. So that 1 minus, because this is 0, equals 1 plus or minus e to the 0, which is 1. So for this to be a true statement, it has to be the minus part. So I'm going to say that this is y equals 1 minus e to the negative x plus 1. I picked the plus or the minus, and it turned out to be the minus. So box it up, I'm done, and I have my last point. Thanks for watching.